Okay, so after we reviewed several evidence that shows that the upper part of the brainstem and cerebellum, which contains 4 times more neurons than the cerebral cortex, as well as a large portion of the prefrontal cortex, does not seem to affect much of our conscious experience, we are now lost where the consciousness can be found. And one highly compelling case is the case of Blindsight, which we are going to look at right now. So let's first look at the behaviors of the patient and also the monkeys, which was described even before the patient. So here's the monkey whose behavior looks quite normal, as you will see, but there is something quite substantially strange about this monkey. Here we go. So this monkey appears to be functionally quite, good and moving around. And in terms of the obstacle objects, this monkey Helen can avoid quite well. But when she is presented with any object, she can't make a discrimination. And as you can see here, she can hold the stuff and then eat it. But when presented with just as a visual object, she doesn't seem to be recognizing it. Okay, and now the second example where same kind of behavior is found in the patient. So here's the behavior of the patient who seems to be homologous in terms of behavior as that monkey. As you will see, this person is the person at the issue. So this person actually claims that he's completely blind and cannot see and also don't want to move or walk. However, the observation from the family and the other doctors suggests that he can actually move and avoid the obstacles. And this is a video. So these two videos, short videos, are so-called blind sight monkey and blind sight patient's behavior. When they are asked to identify or describe or behave to demonstrate the visibility of the objects, then both of them deny seeing. However, when they are forced to move, especially, or locate things, then they can do it very well, including the food or avoiding the obstacles. So this is a now coronal slice. Again, the horizontal slice of the patient TN that was in the movie of the blind sight patient who was walking around, avoiding the obstacles. And as you will see here, this the leftmost column corresponds to the top 50 millimeter above this line, ACPC line, and then the slice goes down, and then you will see that the left side of the parietal cortex here is already missing, and then with the damage becoming bigger on the left side, and then eventually goes on to the right side as well when it comes around the visual cortex, and then both sides of the visual cortex gets lost, and then as you go below, both sides of the visual cortex are damaged. And so this person is particularly, severe case of the, visual disturbance. And, based on this CT or fMRI, MRI images, nobody would expect that, this person can see things. And in fact, this TN claims that he doesn't see anything. nonetheless, he can move around and avoid obstacles, to his surprise as well. And then now, more subtler case of the blind side. Here, I'm going to talk about the two patients, GY and HK, who are both characterized quite extensively, and two of the patients discussed in this Storix paper in 2002. And this is very important paper. It's a bit complicated, but it's important paper. So then first, this image, MRI image of the GY and the HK shows the lesion. And by the way, when you see a radiological convention image, it means that the picture is seen from the bottom and then looking up. So in this case, the image is looking a bit complicated, in the opposite of what you would expect. Front is front and back is back, but the left side is on the right and then right side is on the left. So HK had the right visual field deficit here, and that corresponded to his blind hemifield on the left side. Okay, so this is his HK's phenomenology, and this right side brain lesion is his brain lesion. On the other hand, GY claims that he doesn't see much on the right side, and because of the nature of his blindness, it is gray here. And then corresponding left side visual cortex lesion is here. It's a bit unclear in his case, but in his case, his left hemisphere, okay, so this side, left hemisphere is damaged, and that result in the right side invisibility, okay. So this is the result of the test of the perimetry. If you go to the eye doctor of ophthalmologist, you see, you go to this kind of device, and then some of the lights are flashed in different visual field, and then your task is to say, oh, I saw the light or not, so not, kind of thing. And then this mapping procedure allows you to visualize to what extent of the visual field you are seeing. Okay, so this is a GY and HK's visual field. And this paper by Storig performed two tasks on this patient. First one is a localization task. Here, patients are asked to fixate on the center here with a fixation cross, which is dislocated to the left. And then patients' eye movements was supposed to be monitored, and then patients were asked to touch on this white circle, white square. And then right after their touch, only 180 milliseconds duration. It's really brief, like flash of the light. This very high contrast horizontal grating is presented either on the left side or right side of the grating of the square. Okay, each trial it's either one of the left side or right side. And then patients are asked to touch one of the location, and then after that, they are asked to also report whether they saw anything. Okay, so if I were the subject, I would be looking at this location, and then I see some kind of flash here, and then I see it with a touch, and then report, and then I saw the stimulus. And normally, most people would be able to do this kind of localization of the object only when you see things. However, this blind side patient behaves a bit differently. Okay, so here's the performance of the localization task by HK, who is called absolute blind side patient. In this case, the x-axis of this graph shows the contrast of the stimulus. 9% corresponds to faint to us, but it's definitely visible. And then 46% is almost like a gray looking stimulus, and the 99% is clear black and white contrast, horizontal stripe. So everybody pretty much see it, okay? And then on the other side, y-axis, there are two measures. Let's start with the right side y-axis. So this is a percentage aware report. And this right side corresponds to the white squares, okay? So in the case of HK, if the stimulus is presented on his blind field, which is the left side. So they did the flipping of this, visual stimulus on the other side, and then they presented a stimulus on the left field. And then, regardless of the contrast of the stimulus, HK just said, no, I didn't see anything. I didn't see anything. I didn't see anything. So 0% aware. Okay. On the other hand, the percentage of the correct in pointing which side of the square contained the stripe, there was a dissociation coming from compared to with his awareness report. So overall, across all the contrasts, he's slightly above chance, and chance being the 50%, because every trial there is a stimulus on the left side, more farther left or closer left. And however, HK can do this task slightly above chance, like 55% across all the contrasts, and it becomes significantly above chance when the contrast reaches to 46%. And then at the highest percent, he's much better than chance. But remember that all the trials, HK denies seeing anything. Okay, that's the absolute blind side. And then here's a more complex type of the blind side patient called relative blind side. Okay, here, notice that the percentage of aware report fluctuates, and the fluctuation comes both from the training and also, the stimulus condition. So I wouldn't say too much about this, whether this awareness fluctuation is really specific and significant at 9, 20, 30, 38, and so on. But one thing is clear is that both of this localization response and awareness report was obtained in the same trial. So if you focus on 46% trial case, here in the case of GY, his right hemifield is invisible according to him, and then only 20% of the time he say, oh yeah, I saw something flashed over there, and then all the other trials he say, no, I didn't see anything. And then, however, he was able to say whether the stripe was on the far or near by pointing, and its accuracy is 80%. And also, interestingly, his report of awareness doesn't seem to be correlated with his accuracy. So, it's not a perfect score, and that 20% of the time he makes a mistake. And in that trial, sometimes he say, oh yeah, I might have seen something, and then still he can't point to the correct location. And this is a relative blind side, because compared to absolute cases, patient seems to have some residual vision, almost like in our case of very bad type of the visual side. However, there is a qualitative difference between the relative blind side and our bad eyesight. And okay, so then now we want to apply our knowledge about our methodology on how to discriminate whether the GY in particular is reporting absence of seeing the stimulus, or is he just maintaining a high threshold for saying yes. And this to dissociate that, we can use this receiver operating characteristic. And underlying assumption here is that in a signal detection model, saying that when the stimulus was not present, then the response in the brain is operating like the left side of the sort of the curve. And then when the stimulus is presented, visual cortex generates some kind of activity which looks like right side shifted a mountain. And in each trial, is drawn from both of the distribution. And then if you set the criterion on the left, then you tend to say that, oh, yeah, I saw it, I saw it, I saw it. Everything on the right side of this criterion will will correspond to your yes response. And so one possibility for this blindsight patient is that he has extremely high conservative criterion. And that's the reason why he never says, no, yes, I saw the stimulus. However, somehow the criterion of the report is dissociated from his report. And when they are forced, it operates because they need to land on either left or right. They can do the task much better. So that's one possibility.